Hi everyone, it's Mrs. Summer. Lesson 101.2 is combining like terms. In this lesson, students will be able to combine like terms, apply mathematical grouping symbol operations to combine like terms, and apply the distributive property to an expression to combine like terms. If you recall, the parts of an expression are the coefficients, the variable, which is the letter xy, exponent, which is the number that comes after and above the variable, the term, and the constant term. I want you to think about this. How many of each emoji are there? So take some time and figure out how many of each emoji there are. How I would have solved this problem is that I rearrange the emojis to be the same, like emojis to be next to each other, so that I can easily perform mathematical operations on them. So 2 plus 3, heart kiss emoji, 5 heart kiss emojis. 4 plus 5, I think that means sweating emoji. I don't really know. 4 plus 5 sweating emojis is 9 sweating emojis. And then laughing hysterically emojis is 9 minus 6 is 3 laughing hysterically emojis. So keep this in mind when we change for the next slides, when we start adding letters instead of emojis. It's the same concept with combining like terms. So now if I was to ask you to combine like terms using this expression, 15 plus 4x minus 10 minus 5x plus 6 plus 3x minus 2. To be a like term, the variable and the exponent must be the same. If two or more variables are connected to each other by multiplication or division, they are one term. So in order to combine like terms, we need to regroup the terms so that the like terms are next to each other. So how I did this is I moved my constants all next to each other. And if you notice that the sign that comes immediately to the left of a term is the sign that belongs to that term. So 15 minus 10 plus 6 minus 2, and then I regrouped them, and then 4x minus 5x plus 3x. So I rearranged my expression in order to have my terms next to each other. So when I'm combining like terms, I add or subtract the coefficients only. This is really important. You only add or subtract the coefficients, not the exponents. So 15 minus 10 is 5, plus 6 is 11, minus 2 is 9. So I have 9 here. Then I have 4 minus 5, which is negative x, plus 3x is equal to 2x. So my combined like terms and my simplified expression is 9 plus 2x. Your turn. Take the time to simplify the expressions by combining like terms with this problem, this one, and this one. To review the previous problems, simplify the expressions by combining like terms. So my dh to the fourth plus 3dh to the fourth. Remember, if there is nothing in front, we put a 1. So I have 1dh to the fourth plus 3dh to the fourth is 4dh to the fourth. This problem, 45r to the fifth minus r to the fifth. Remember, 45 is my coefficient, and if there's nothing in front, we put an imaginary 1. So 45r to the fifth minus 1r to the fifth is 45r to the fifth. If you noticed, my exponents stayed the same in this. We didn't change anything about the exponents in the term. Only the coefficients. So this problem simplify the expression by combining like terms. So I have 4h squared b squared plus 3h squared b minus 5h squared b squared. So I need to rearrange so my like terms are next to each other. So what I did is I put my 4h squared b squared and my negative 5h squared b squared next to each other. And here there was just a lone term, so we left it alone. So then I did 4 minus 5, which is negative. You can put a 1 there if that makes you feel more comfortable. Negative 1h squared b squared plus 3h squared b. So here we're going to combine like terms, but we're going to add in grouping symbols. Grouping symbols are another word for parentheses. So if there's addition between the grouping symbols, just remove the grouping symbols, rearrange, and combine like terms. So we rearrange this, and I put all of my terms next to each other. And then I performed my operations. So I did 6f squared. That stayed the same because there was no other like term. 4f minus 3f is just f, plus 3 plus 7f cubed. The way I wrote it over here, typically when you are writing an expression, the exponents go down when you are writing them. If you wrote it like this, that's perfectly acceptable, and I would accept that as the correct answer. But remember, to be a like term, the variable and the exponent must be the same. If two or more variables are connected to each other by multiplication or division, they are one term. Now, here's where it gets a little tricky. If we are combining like terms with grouping symbols, but there is subtraction between the grouping symbols, we have to change the sign of the terms in the group being subtracted. So the group being subtracted in this example would be 7f cubed minus 3f. And then remove the grouping symbols. So what I did, what we'll talk about next is distribution. I distributed the negative. So I was left with 6f squared plus 4f plus 3 because this part, we don't change. Then this was a positive f cubed. It's now a negative f cubed. This was a negative 3f, so I changed its sign to a positive 3f. Then I rearranged them, so 6f squared plus 4f plus 3f plus 3 minus 7f cubed. And my answer would be 7f cubed plus 6f squared plus f plus 3. So here, if you would have written 6f squared plus 7f plus 3 minus 7f to the third, it would have been correct. I would have marked it correctly. So now you try. Simplify the expressions, this one, and this one, by combining like terms. In this expression, it's being subtracted, so I need to change the sign of the terms that are being subtracted. So I'm left with negative 9yz cubed plus 4yz squared minus 8yz cubed plus 11yz squared. When I rearrange it to put my like terms next to each other, and then I simplify, I get negative 17yz cubed plus 15yz squared. In this problem, I'm adding the two grouping symbols. So all I have to do is remove the grouping symbols and rearrange. And so I'm left with 7e squared plus negative 4e squared plus 5e minus 3e minus 4 minus 4. And I'm left with 3e squared because 7e squared plus negative 4e squared is 3e squared. 5 minus 3e is 2e. And then negative 4 minus 4 is equal to negative 8. On this problem, I have, once again, I am subtracting one grouping symbol from the other. So this grouping symbol stays the same. This one, I have to change the sign of the terms inside the grouping symbol. So what I did was negative 9, so minus a negative 9r turns to a positive 9r. A negative 7 turns to a positive 7. Then I rearranged to put my like terms next to each other, simplified to get 16r plus 2. Simplifying expressions with distribution. So distributing a constant. So a constant is a term that has no variable attached. So if I wanted to distribute this 2 to everything inside here, I'm going to take the 2 and I'm going to apply it by way of multiplication to everything inside. So what that means is then I end up with 2 times 4x cubed minus 2 times 3x. So here I am just multiplying the constant by the coefficient in the grouping. So I have 2 times 4, which is 8x to the third, minus 2 times 3, which is 6x. We don't change anything about the exponents. You are just multiplying the constant, multiplying the constant by the coefficient. So you try. Simplify these expressions by distributing the constant and combining like terms. In this question, I have 4 times the quantity of 8z cubed minus 11z squared. So I am going to distribute that 4 to each term. Then I'm going to multiply 4 times 8 times my coefficient is 32 minus 4 times 11, which is 44. Notice I didn't change anything about my exponents. In this question, I have a negative 3 times the quantity of 3x squared minus 5. I'm going to distribute the entire negative 3. You don't just distribute the 3. This negative is a part of that 3, which means we distribute it. So negative 3 times 3 is negative 9x squared. Minus negative 3 times 5, which is negative 15. Now remember, if you're subtracting a negative, it turns into a positive. So I'm left with negative 9x squared plus 15.